So within this lag phase, it adjusts to everything, and during this phase, it should the bacteria, whatever it is there, it takes some bacteria they take 1 hour, some bacteria they take 1 day. So it depends on bacteria to bacteria. So it varies from some hours to 1 day. Okay. So after this, it enters the log phase, that is exponential phase. During this phase, the growth is very rapid or very fast, as it has adjusted to all the nutrients and everything, and all the nutrients are available also. So it immediately divides and divides, as I have shown you in the exponential way in the geometric progression. The cell doubles and doubles and goes to the peak stage. Okay, so during this stage, it is very vulnerable to any changes. If you change any of the nutrient or if you change any of the condition, then it would be difficult for the bacterium to grow. Like if you expose the bacterium to the radiation, or if you expose the bacteria to some antibiotic, then immediately the growth will be stopped. So this is the most important phase. Okay, so during this phase, there is a lot of division in the cell. Then next it goes to the stationary phase. So during this stationary phase, the number of the bacterial cells growing is always equal to the number of bacterial cells that are getting here, for example, in the exponential phase, he has given the example E. coli divides in every 20 minutes, and for Staphylococcus aureus the doubling time is 30 minutes, and for that is nothing but the generation time, the how much time it takes to get doubled, that is called as generation time. So it depends on bacterium to bacterium. I have said in the exponential form geometric progression it grows. Okay, so but in the stationary phase, the number of the bacteria growing are equal to the number of the bacteria dying. Why this is because during this, as the bacterium grows, it releases several toxic chemicals, the waste materials, the toxic metabolites, and also it synthesizes some inhibitory compounds and antibiotics also. We all know that bacteria synthesize antibiotics. Okay, so all these are getting released into the medium. So that is in turn disturbing the bacteria itself, because they are all accumulating, and also the nutrients are getting depleted, because all the growth medium that is used up by the microorganisms. So when these waste materials, toxic metabolites and antibiotics are released in the medium, it decreases the pH and also affects the temperature. So as a result, the number of cells undergoing division is equal to the number of the cell death. So it goes in a plateau way, that is, there is no growth, no death, that is all equal. Okay, so after this comes the death phase. So by this time, all the nutrients are depleted, everything is completed, and the number of dead cells increases over here. There is light division in this. There is division is going on in the stationary phase, but in the case of death phase, there would be no division. The bacterium completely loses its ability to divide. Okay, to divide or to reproduce, and due to these unfavorable conditions, the number of dead cells, they get increased a lot, and thereby the growth stops. Okay, some bacteria, they form endospores during this stage, and thereby they survive during this phase. Okay, but basically any bacteria, it grows in this way, and for the growth curve of the bacteria, you have to mention all these 4 phases and also the curve. So now how to calculate the generation time? I have already explained generation time is nothing but the time taken for the bacteria to double, that is from 1 to 2. How much time does it take? Some bacteria may take 30 minutes, some may take 20 minutes, some may take 1 day. That is nothing but the generation time of that particular bacteria. So if you can observe, in this graph, the first blue line, it is pointing out at 60 in x-axis and 0.2 on y-axis. 0.2 is nothing but the concentration of the bacterial cell. So 0.2 is becoming 0.4. That is nothing but doubling, right? So the time required for 0.2 to become 0.4, that is 90 minus 60. That is nothing but 30 minutes. That is nothing called generation time, and during this generation time the cell is getting doubled. I hope you are understanding. So how do we calculate this generation time for all the bacteria? Like for all the bacteria we can't go and check on the graph, right? So this is the derivation of that point. Okay. So now let us calculate this. Let n0 is equals to the initial population number, that how many bacteria we are initially introducing into the medium. Then nt is equals to population at a random time t. Take the time as t. That may be any kind of time, any n number of time. Then capital N is equals to number of generation. This should be the small n. Okay. It is printed incorrectly. Please correct it while you noting down the notes also. It is small n. Small n is the number of generations in time t. That is number of divisions or number of generations. Okay. So now the graph goes in this way. The equation is capital NT is equals to N0 into 2 to the power of N. So I have always given, for example, it is the first division. So after the first division, how many cells will be there? Let us assume that N0 is equals to 1. You are starting with 1 cell, and 1 into 2 to the power of 1, that is after 1 division, that is 2 to the power of 1. So 1 into 2 to the power of 1, 2 to the power of 1 is 2. So 1 into 2 is 2. So this is how they derived this formula, that is after first division number of cells would be initial number of cells into 2 to the power of n. Okay. So now we apply logarithm to this. So log nt is equals to log n0 n0 plus n log 2. 2 to the power of n, after applying logarithms it becomes n log 2, and for multiplication if you apply logarithm it becomes plus. Okay. So log nt is equals to log n0 plus n log 2. So now let's make small n as the subject. So small n the subject, so bring log n0 to this side. So it becomes log nt minus log n0. Then you divide, then you make n as subject. So divided by log 2. Now this is the equation. N is equals to log nt minus log n0 by 0.301. This is nothing but value for log 2. Okay. Now this can be expressed, there is a constant called growth rate constant, that is K, mean growth rate constant. That constant is given as number of generations or number of divisions per unit time. So now we take the value of n in this equation. We have generated the value for n, small n. So now we substitute that value in this equation, k is equals to n by t. So that equation is k is equals to log nt minus log n0 by 0.301 into t. Okay, clear everything? So now we already know log nt is equals to 2no. For example, the time is taken to double its size. So why we are taking it as 2n0? Because it is getting doubled. Nt should be, if the one cell is becoming the 2 cells, then naturally nt will be 2 into n0. This is the what example I have explained here. 2 to the power of n. So first number of cell is 1. 1 into 2 to the power of 1, that is 1 into 2, 2. So it will be always 2 times the initial number. Okay, in any time you take, it would be, for the first division it would be doubled. So let us take nt is equals to 2n0. So now substituting this in this equation, k is equals to log nt minus log n0 by 0.301 into t. So log 2n0 minus log n0 by 0.301 into t. So this t also becomes the g, that is generation time. Generation time, what is generation time? The time which is taken for a cell to double. As we are substituting log 2n0 for nt because it is the first division and the cell is becoming doubled. So that is why we have substituted log 2 and 0. In the same way, the T also becomes G, that is generation time. That is the time taken for a cell to get doubled. As we are taking NT is equals to 2 and 0, in the same way we are taking T as G. Okay. So let us solve this. Log 2 n0 minus log n0. Let us take log 2 outside, that is log 2 into log n0 minus log n0. In logarithms, multiplication becomes plus. So log 2 into log n0 minus log n0 becomes log 2 plus log n0 minus log n0. This whole thing is getting divided by 0.301 into G. Okay. So now log n0 minus log n0, that is nothing but 1. Okay. So now log 2 value is the log n0 minus log n0 becomes, log n0 minus log n0 gets cancelled. So it will be on the whole 0. So log 2 by 0.301 by G. Log 2 value itself is 0.301. So log 2 and 0.301 also get cancelled. So it would be just 1 by G. Just listen to this video again and again. Don't get confused. Okay. Log 2 plus log n0 minus log n0. And log n0 get cancelled. Then it becomes 0. Okay. So log 2 plus 0 is log 2. Then log 2 by 0.301 G. Log 2 value is 0.301. So 0.301 by 0.301 G. So it becomes K is equals to 1 by G. Okay. K is nothing but mean growth rate constant and G is mean generation time. Okay. So this is, you can change it always. K is equals to 1 by G and G is equals to 1 by K. In this way we can either calculate growth rate constant or we can calculate growth rate constant, that is K. Clear with this equation or shall I explain it again? So we are applying logarithm to nt is equals to n0 into 2 to the power of n, that is log nt is equals to log n0 plus n log 2. So n we are making n as a subject, so take log n0 to other side, it becomes log nt minus log n0, then divided by log 2, then n becomes individual. Okay. N is equals to log nt minus log n0 by log 2. So now the value of log 2 is 0.301. So now we have the equation of growth rate constant as K is equals to n by T. So that is nothing but we are substituting value of n in this equation. And we are changing nt as 2 log 2 n0 because it is getting doubled. We are taking it as generation time, that is the cell is getting doubled from 1 to 2 cells. So let us take log nt as log 2 n0 and t as G. Then you get this equation finally. K is equals to log 2 n0 minus log n0 by 0.301 into G. Okay. So log 2 you take it outside. But in the case of logarithms, multiplication becomes plus. So log 2 plus log n0 minus log n0 by 0.301 G. Log n0 minus log n0 gives 0. So log 2 value is 0.301. 0.301 and 0.301 get cancelled. So finally the equation is K is equals to 1 by G. Okay. I hope it is clear. So this gives the growth curve of the bacteria. You have to mention all these 4 phases. You have to describe about the growth and how it is measured using. You can explain the Beer-Lambert's law also. You can give not the whole Beer-Lambert's law. You can just say that the growth can be measured using Beer-Lambert's law using a spectrophotometer, and thereby based on the optical density, or you get the concentration of the bacteria, and based on that we draw a curve using, on the x-axis it would be time, and on the y-axis it would be logarithmic number of cells. Don't forget log, because we are applying logarithm for the calculation. So logarithmic number of the cells on the y-axis, and then if we plot a graph we get 4 phases. You have to explain all the 4 phases, and then you have to explain about this cell doubling and generation time and this equation. Okay, I'll forward you this notes also, so keep note in this. Okay, so if any doubts you can ask me again.